Welcome back to the Apex Waves channel. Today we're highlighting one of the most unexpected and creative uses of LabVIEW we've ever seen, solving a Rubik's Cube. Yes, LabVIEW, best known for data acquisition, instrument control, and industrial testing, is being used here as a full-blown simulation engine for solving a three-dimensional logic puzzle. And the best part? The whole thing was shared on the NI forums by an incredibly talented LabVIEW developer. We all know LabVIEW is powerful for data acquisition and hardware control, but this project highlights its versatility as a visual programming language for pure logic too. The user on NI forums created a fully interactive Rubik's Cube simulation, complete with a 3D representation of the cube that you can rotate, scramble, and most impressively, solve using built-in algorithms. The front panel serves as the 3D cube interface, built from custom-drawn graphics using LabVIEW controls and indicators. You can simulate manual rotations by clicking face buttons, scramble the cube with random moves, and then solve it with a press of a button. Behind the scenes, the block diagram runs a set of functions that mimic the logic of well-known cube-solving methods, such as the beginner's method or layer-by-layer solving. Each cube face and piece is stored in an array or cluster, and transformations are handled with array shifting and rotation logic, provided just how far LabVIEW's control structures can go. On the block diagram side, things get even more interesting. Each cube face is represented using arrays or clusters, specifically 3x3 matrices for each face. The logic behind every rotation is handled using array shift operations and matrix transformations. When a user rotates a face, either manually or as part of the solve algorithm, LabVIEW updates not just that face's array, but the adjacent edge strips of the connected sides, preserving the cube's mechanics. Each color is tracked by an index system, and the block diagram uses case structures to interpret which face is being rotated and in which direction. The code accounts for all 18 possible moves, 9 faces by 2 directions, similar to how algorithms are written in standard cube notation like RU, etc. The cube's solve function is built using a simplified layer-by-layer approach. That means solving the white cross first, then corners, then middle edges, then yellow face, and so on. Each stage includes embedded logic to detect patterns and decide which rotations to apply next. While it's not quite as fast as Kotsiemba's optimal solver or two-phase algorithms used in speed cubing apps, it's impressively accurate and entirely built in LabVIEW. The developer even included a button that lets you watch the solution happen step by step, which is both satisfying and educational to watch. What makes this project so compelling is that it's not hardware-driven. It's purely LabVIEW logic. It combines pattern recognition, matrix transformation, and algorithmic sequencing, all visualized in a clean, interactive UI. It's a great example of how LabVIEW isn't just for data acquisition. It can be a tool for simulation, algorithmic development, and even fun visual logic puzzles like this. If LabVIEW can model, manipulate, and solve a Rubik's Cube, it can absolutely handle the logic in your automated test setup. Projects like this also make LabVIEW approachable for students and developers learning programming logic by giving them something visual, familiar, and interactive to work with. The original post can be found on NI forums, where the developer shared the VI files and course code. You can find the link in the description below. If you're looking for a fun weekend project or a creative way to teach logic and array manipulation, this is an awesome place to start. And if you're using LabVIEW in an academic setting, this is also a great demonstration tool for programming fundamentals using a familiar real-world puzzle. At Apex Waves, we love seeing the boundary-pushing ways people use NI tools. We're constantly inspired by the NI community's creativity. And this project is a perfect reminder that sometimes the most interesting solutions come from outside the box, or in this case, inside a cube. Whether it's solving puzzles or solving mission-critical test challenges, we're here to support your journey with the hardware and insight you need. This concludes today's video. If you have any additional questions, please visit our website at apexwaves.com, where our dedicated team is ready to provide the support you need. Thank you for watching. Don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.